Hi everyone. So today we're going to be focusing on locating points in relation to circles. So what I mean by that is if you had a circle in the coordinate plane and you were given a point, we're trying to determine where that point is located. So is that point inside the circle, outside the circle, or on the circumference of the circle? Before we get into that, what I want to do is point out how the equation of a circle is similar to the distance formula and explain why we're able to identify where a point is in relation to a circle based on the equation. So if you guys remember back to the distance formula is the square root of the difference in our x's squared plus the difference in our y squared. So x1 minus x2 squared plus y1 minus y2 squared. If we take a look at center radius form of a circle, we have x minus h squared plus y minus k squared is equal to r squared, where x, y is a point on the circle and h comma k is the center. So if you notice in red here, the inside of the distance formula looks a lot like the left side of our circle equation. The reason is because we're actually finding the radius is actually the distance in between the center and a point that's on the circle. So if we actually solve for our radius, you're gonna notice that it's gonna look a lot like the distance formula. So that's what I did here. So what I did is I flipped our equation so that way r squared is on the left side of the equation, similar to d for the distance formula. So we have r squared is equal to x minus h squared plus y minus k squared. Then in order to solve for r, we take the square root of both sides. And what we notice is this final equation for our radius looks almost identical to our distance formula. Well, the reason is because your radius is really just the distance between the center and any point that's on the circle. Okay, so now the reason that I'm pointing this out is in order to locate where a point is, we want to figure out how the distance between the center and the point that's going to be given relates to what the radius is. Since we know that all points on a circle are equidistant from the center, that distance is known as the radius. By comparing the distance from the center to a point, comparing that to what the radius is, we can figure out where the point will be located. Okay, so the steps that we're going to follow today, we're going to start by writing out the equation of the circle and center radius form, and we're going to substitute in the given point for x and y. Then what we're going to do is we're going to simplify. We're going to try to compare the left side of the equation to the right side of the equation. The left side of the equation is going to represent the distance squared that the point is from the center of the circle. The right side of the equation we know is going to be our radius squared. So then what we're going to do is compare the left side of the equation to the right side of the equation. The way we're going to do that is as followed in step 3. If the left side of the equation is less than the right side, that means that the point is going to be located inside the circle. The reason for that is because the distance from the center to the point is less than the radius squared. So because of that, the point's going to be inside. If the left side is equal to the right side, that means that the point is going to be located on the circle because it means that the distance between the center and the point is the same as the radius. And then finally, if the left side is greater than the right side, that means that the point's going to be outside the circle because the distance from the center to the point is greater than what the radius is. Okay, so for our examples today, for number 1, we're given the equation of a circle, x squared plus y squared equals 25, and we want to know where the point 3, 4 is located. Now, a couple things I want to point out. Based on the equation of this circle, our center is going to be located at 0, 0, and then our radius is the square root of 25, or 5. Okay, so what we're going to do is take our equation of the circle, rewrite that in center radius form, which it's already in center radius form for us. So we're just rewriting the equation. Then what we're going to do is substitute in our point for x and y. We're going to simplify and then compare the left side and the right side. So if we plug in 3 for x, we've got 3 squared plus 4 for y. So 4 squared is equal to 25. And we're seeing if it's equal, if it's greater than, or if it's less than. So 3 squared is 9 plus 16. We're seeing how that compares to 25. 9 plus 16 gives us 25. which is equal to 25. So because the left side of the equation is 25 and the right side of the equation is 25, that means that the point 3, 4 is on the circle. So this point is on circle. So it's located on the circumference of the circle. All right, moving on to number 2. So here we have center radius form of the circle, x minus 2 squared plus y plus 5 squared is equal to 49. And we have the point 5, negative 2. So again, 5 is going to be our x, negative 2 is going to be our y. Let's write out our equation in center radius form. So x minus 2 squared plus y plus 5 squared. We're seeing how that relates to 49. So we're going to substitute in 5 for x, negative 2 for y. So we have 5 minus 2 squared plus negative 2 plus 5 squared is equal to 49, or not equal to. We're trying to figure out how that relates to 49. 5 minus 2 squared is 3. Negative 2 plus 5 is 3 as well. We're seeing how that relates to 49. 3 squared is 9 plus 9. We're seeing how that relates to 49. 9 plus 9 is 18. 18 is less than 49, meaning that your point, 5, negative 2, is inside the circle. Now, the reason that the point is inside the circle is because the distance between the center and the point is squared is less than the radius squared. All right, moving on to number 3. So for number 3, our point is 3, 3. We're trying to figure out if that point is inside, outside, or on the circle. Okay, so we'll start off with the equation of the circle. So x plus 1 squared plus y plus 3 squared is equal to 30. Now we're going to substitute in 3, 3. So 3 plus 1 squared plus 3 plus 3 squared. We're seeing how that relates to 30. 3 plus 1 is 4 squared, plus 3 plus 3 is 9 squared. We're seeing how that relates to 30. 4 squared is 16. 9 squared is 81. Seeing how that relates to 30. So we get 97, which is greater than 30. So because the left side is greater than the right side, the distance between the center and the point is greater than the radius squared. So because of that, our point is going to be outside the circle. All right, and finally, example number 4. So we've got our equations x plus 4 squared plus y minus 9 squared is equal to 100. We want to see where the point negative 10, 1 is located. Okay, so let's start by writing out our equation. X plus 4 squared plus y minus 9 squared is equal to 100. We're going to substitute in negative 10 for x and 1 for y. So we've got negative 10 plus 4 squared plus 1 minus 9 squared. Seeing how that relates to 100. Negative 10 plus 4 is negative 6 squared, plus 1 minus 9 is negative 8 squared. Seeing how that relates to 100. Negative 6 squared is 36, plus negative 8 squared is 64. See how that relates to 100. 36 plus 64 is 100. So because the left side of the equation is 100 and the right side of the equation is also 100, that means that the distance between the center and the point is the same as the radius. So because of that, our point is going to be on the circle. All right. Your homework tonight is to finish up the weekly assignment. Please make sure that you submit it by tomorrow, and then keep an eye out for the Edge Elastic assignment for this week. Have a great day, everyone.